This particular version of Arduino is Arduino UNO, that you can see here it is written, and there are other boards like Arduino Nano, Arduino Dio, Arduino Mini, like that. And for particular this experiment I have chosen this because this is easy to explain in this board, and this is also much cheaper board. You can get this Arduino board on Amazon of around 400 to 500 rupees, and you can always buy this from other stores, other electronic stores. So as you can see, there are various pins here. This set of pins are analog input pins. As you can see that A0, A1, A2 up to A5. Through these analog input pins, you can give analog voltage as input to this microcontroller. It can read analog signals, but this particular board cannot give analog output signal. It can read input signal as analog, but output signal it will always give in the form of digital mode, digital signal. Now these set of pins are power pins. Here you can give V in, where you can give input power, 5 volt to 9 volt generally given, and ground is connected to the ground, that is 0 volt, and you can also get regulated output 5 volt, 3.3 volt from these two terminals, adjacent terminals. And the terminals that are given here on the other side, these are digital input and output pins, where you can get both input and output in the form of digital signal. If you have your signal in the form of 1 and 0, that is digital signal, then you can directly give the input from this side, that means on these terminals. And also any signal that this microcontroller can give as output will be available here. That means this will be always digital signal, not analog signal. And there are other ports such as ICSP, where you can connect your computer to this board through ICSP protocol, and this USB port has been given to connect the board through USB connection with the computer. And there is a particular cable that is supplied with this board. This is called A to B cable. This terminal is known as B terminal, and this is A terminal, known to you, I think. And this terminal can be connected here, and the other terminal goes to a computer USB. Okay, so through this connection, USB connection, you can program this microcontroller for the specific purpose that is needed, and also you can get output signal to the computer through this USB. You do not require to use these digital pins for the output. You can get directly output through this USB. Okay, and this socket is given if you want to power this device with the help of adapter, 12 volt adapter, then you can connect the 12 volt adapter here directly. Okay, let us now use this microcontroller in an experiment which I will show you, and this experiment will require some other parts. Let me show you those parts. It will require this one is called light dependent resistance. The resistance between these two terminals depends upon the flux of light that is falling on this surface. Okay, so if I show you with the help of a multimeter, see, now it is showing about 8 kilo ohms of resistance between two terminals. Now if I cover the surface with my finger, you can see that it has increased. Okay, so if the flux is more, light flux is more, then the resistance is less. Okay, so inverse relationship with the flux of light. Okay, so we can use this device as a light detector, that I will show you now how we can use this as light detector. And for this experiment I will require another component, that is a normal carbon resistance. This particular resistance has the value of 12. So as you can see, the first mark is brown, the second mark is red, and the third mark is orange. So according to the coding of resistance, we can find out its value to be 1, 2, and then 10 to the power 3, which is 12 kilo ohms of resistance. Okay. In this diagram, it has been shown that how to connect the components. The LDR and the resistance has been connected in series, and one end of the LDR goes to the 5-volt power supply, and the other end of the circuit, that is the endpoint of the resistance 12K, goes to the ground. Okay. Now the junction point of the LDR and the resistance 12K goes to the microcontroller input, analog input. Now what happens in this case is that when a beam of light will incident on the LDR surface, that will decrease the resistance across the LDR, and as a result current through the circuit will increase. Since current increases and the resistance of 12K remains constant, so potential difference across the resistance 12K will increase. Now the case is that when the light beam, the intensity of the light beam will increase, the potential difference across the resistance 12K will increase accordingly. Now we are going to record this potential difference across the 12K resistor through microcontroller, and the reading will give us a value which is proportional to the intensity of incident light. Okay. So I have constructed the circuit on breadboard here. As you can see that this is LDR and this one is the 12K resistor. These are connected in series, and one end of the LDR goes to the 5-volt regulated power from the Arduino, and the other end goes to the ground. Okay, as you can see here, and the junction point of the LDR and the resistance has been connected to the A0 input, analog input of the microcontroller, Arduino microcontroller. Now we are going to program this microcontroller with the help of which we can record the readings. Okay, so let us see how that is done. Now I am going to connect this Arduino UNO board to my computer through this USB connection. So it has connected. Now I'll have to open the IDE. You can download this from Arduino's official website, that is arduino.cc. As you can see here, you have to move to the software section, and then you have to choose your version of operating system, and then the corresponding software you can download from here, and then you have to install the software to your system, and then you can program your Arduino UNO board. Okay, Arduino UNO or any other version if you have, you can then program your microcontroller board. So here in the tools section, you can choose your board here, whether you are having Arduino UNO or Nano or other versions of Arduino. You can choose it here from here, and then you'll have to choose the port where it is connected. In my case it is COM4, so it has been connected to COM4. Here I have chosen COM4, and then you can directly write your program here and then upload this program to the microcontroller. So the language that it uses is Arduino language, which is very similar to C language, and with the help of that I can program the microcontroller to do a particular task. Okay, so in this case, in this program I have just declared a variable, float variable I, which corresponds to the intensity of light that will fall over the LDR surface, and initial value I have given here 0.0. Okay, within this setup section, I have to declare the pin mode first. Pin mode means whether the pin that I am using for getting the input data. Okay, so here I have used A0 input, analog input for the input data. So here I have declared pin mode A0 input. That means A0 terminal will be using as input terminal, and then I have to declare the baud rate of the serial connection, which has been declared here 9600. You can give any other value also here, and then comes to the loop section, which runs over and over again. Here I have given the first line, as you can see, I equal to analog read 80. That means it will read the signal that is getting from A0 input, and then it will store into the I variable. Okay, and in the next line I have written serial.println I. That means it will print line by line in the serial port. Okay, there is a section here, serial monitor, where you can get the values that will appear here. You can see the values here, and also you can copy and paste it to your any file in order to if you want to use it later. Okay, so after I have written this program, I'll have to upload this to the microcontroller. In order to upload, there is a button here, upload button, as you can see. If I press here, then first it will check whether the program that I have written is correct or not. Then it will compile it, and after that it will upload it to the microcontroller board. Now the compiling process is running. Let us wait, and then it will upload the code to the microcontroller board. So now it is uploading. Done uploading. That means it has successfully uploaded the code to the microcontroller. Now if I open the serial monitor, you'll see that it will get the values. As you can see here, the values are coming here, and the values here are about 600, 590, like that. It is varying very fast because it is continuously running, and if I want to view these values in a bit slower manner, then I have to give one more step here. Here after serial, just before serial println, let me give here a command delay. Within that bracket, I'll have to write the time period in milliseconds. So let me give here 100 milliseconds. That means it will give me 10 values in 1 second. Okay. Okay, now let me upload it again. So it is uploading now. It is uploaded. Okay, let me again open the serial monitor and let us see what has changed. Now you can see the values are now visible clearly, not changing very fast, and you can read the values. So values are nearly 600. It is very near to 600. Some values are 600, some values are 580, like that. It is varying because the intensity of light that is falling over it, it is not continuous. It is also varying very frequently. And there is another section here, serial plotter, where the values that it will print on the serial monitor can be plotted here directly. Okay, as you can see, it is being plotted over the y-axis. The values, the lowest value that it has plotted is near about 582, and the highest value is near about 600, just above 600, 603 or like that. Now if I cover the surface of LDR with my hand, the values has decreased, as you can see. Okay, so evidently the intensity of light that is falling over the LDR surface are now less, and therefore it can be seen on the graph, as you can see. Now if I uncover it again, then you can see the values increased and it is showing a higher value. Okay, so in this manner, with the help of a microcontroller, we can record various data through your computer, and you can also use it for monitoring, for making various monitoring system and all that. So this was a very small demonstration for you, and if you are interested to know more about this, you can contact me. This is my email address, and if you have any query, you can ask me. I'll try to answer it.